Get Certified Together program is created by Technocofe, your free online knowledge sharing website based out in London.
Or which server is assigned by what IP, and you have to automate that process. Let's be practical, you cannot do anything manually in that particular scenario. DHCP stands for Dynamic Host Configuration Protocol. There are a lot of solutions which can take care of DHCP. You can even use your firewalls, or you can use your routers, your network equipments to act as a DHCP server. Now that DHCP server will do nothing but assign a unique IP address from a particular block. Hey everyone, welcome to another episode of Get Certified Together series. This is episode number 42. I am recording today and we are still continuing on the journey of CCSP. We are onto the cloud security operations domain and we have covered a lot of topics around that. We have discussed about various virtualization management tools, various security strategies around physical infrastructure, like those badge cards, identity cards, how you can actually control your access in and around the physical infrastructure, even the remote or local control access, how you can secure your RDP. Everything we have covered bits and pieces around that, and of course we are not going that much into the detail. Most of the topics, if you by now can understand, are kind of repetitive, because when we started up our whole journey, we started up from the cloud infrastructure basics. Then on top of that, we discuss in and around various things. We discuss about application data. We of course discuss about the infrastructure security itself. In security and operations, we are more onto how we can operate and manage day-to-day tasks or day-to-day activities around those cloud building blocks. And that's the whole idea. Means that's what we are trying to achieve here in this particular domain. Now, cloud security operation in itself have a lot of things, and we started again into those layered architecture, and now we are moving more and more towards actual infrastructure networking and how those applications which are deployed on top of the cloud, how we can manage the operational aspects around that. So of course, a lot of interesting things coming out in today's episode as well. I know I have promised that I'll be wrapping up cloud security operations before Christmas holidays, and we are almost into mid of December when I'm releasing this episode. I think it will be coming out somewhere after 3 or 4 days after I record that, so it will be almost Christmas holidays. Good thing is I will not be taking any break, because unlike last year when there were holidays, I used to stop myself from recording because of the kids in the house and all the noise and all the distractions around me. What I did this time is I have switched my place from recording inside the house to my garage. So I myself have kind of like a cave in which I can record anything. And of course, because when I'm recording from the garage, it's just next to my driveway. So maybe now and then you will hear some background noises from the cars or some vehicles who are going in and out. But all in all, it's still better than recording in the house with kids in the background. So the crux is, hopefully I'll be recording more and more episodes without taking any break in the Christmas holidays as well. And we might be able to achieve our target of cloud security operations. Although when I look into those topics from the DCO, so if you haven't downloaded DCO yet, just go into the ISC Squared website and get hold of that document. So if you go through the syllabus, you can see that cloud security operations is actually indeed a big topic. Although all the topics are kind of touching everything. You have everything around SSH, RDP, how you can log in into the system, what is the baseline configuration, what are different network security protocols. Everything is touched in the cloud security operations, so that's why it's a big topic. I'm not promising that we will be able to achieve that during the Christmas holidays, but I'll try my best. And of course, the more episodes, the more knowledge, the merrier it is, and we can of course learn a lot of things. So that's the whole idea. Means I want to record as many things, as many information as I can. Now, of course, winters are here, so if you are in and around the northern hemisphere, then you must be feeling the chill. temperature is. Sometimes it drops below zero as well, so it's getting colder and colder, but we should be doing every bit around saving our environment, saving our climate. We are still in a good phase. Make sure that you help in doing your bit of the environment as well. I'm really thinking of switching my car from petrol to the electric ones, but I'm not really sure how good they are. So if you have any suggestions around that, then please just send me over. I'll be also taking my time to revamp my TechnoCoffee website. So if you are looking into that website, then I'm so sorry, but most of the stuff is quite old. I didn't get really chance to put the latest stuff onto that. That's kind of my new year resolution, that I'll be putting more and more stuff onto the TechnoCoffee website as well. So of course, if you want to refer that website for anything, then you can have a look there. I'm paying for that website every year, and it doesn't make sense to just keep that website running if I'm not doing anything onto that. I have regular visitors there, so I have some kind of inspiration to keep it running, but of course those visitors won't be coming again if the content is 2-year-old or 3-year-old. So I'll be putting more stuff onto that as well. So more episodes, more content on the website, and of course day job is also there. A lot of things to do in the life, a lot of things to do in the 2024. I am excited. Hopefully you guys have your own resolution, hopefully you have your own targets as well. Of course CCSP is there, and we have to get it together, and we have to get certified together. So let's quickly move into today's episode and cover some of the topic. Before moving to that, let's take a quick short break. Alright, so I was going into the topics which I covered in the last week episode, and I missed a major topic which was part of syllabus but I didn't cover last time. It was around DHCP. So we have already discussed about DNS, domain name systems, where you resolve your host names to an IP address, so you don't have to remember IP address always. It's of course quite useful in any kind of infrastructure, be it private cloud, be it public cloud, or be it the older legacy way of doing the networking. So we have covered that bit, but I forgot to cover DHCP. Now DHCP is nothing but a protocol which you use to assign IP to your servers. Now, like DNS, where you cannot remember your IP addresses, you also cannot remember what IPs are allocated to which server. If you are assigning it manually onto each server, that's fine if you are running 5 or 6 servers or 7 or 8 virtual machine, 3 or 4 containers, or a small Kubernetes cluster. But when you grow your infrastructure, when you have 50 or 100 application, you have 70 or 80 servers, how are you gonna manually assign those IPs? And if you are indeed going into the manual route, how you gonna make sure that you are only assigning the unique IPs, because we can't have overlapping IP addresses in the same network. This can break a lot of application. So of course you need some kind of tracking on which application or which server is assigned by what IP, and you have to automate that process. Let's be practical, you cannot do anything manually in that particular scenario. DHCP stands for Dynamic Host Configuration Protocol. There are a lot of solutions which can take care of DHCP. You can even use your firewalls, or you can use your routers, your network equipments to act as a DHCP server. Now that DHCP server will do nothing but assign a unique IP address from a particular block or particular subnet to each new server whenever you boot it up. So instead of anyone logging into that server and assigning the IPs manually, DHCP server will take care of that. Of course, when there is a centralized server assigning the IPs, then that server itself will make sure that no overlapping IPs or no IPs are assigned twice. So every server is having, or every application is having, a unique IP address. Of course, DHCP is handy in that case, right? Beside DHCP, we also have IPAM system in our infrastructure. I think covered this in cloud infrastructure basics as well. IPAM system is nothing but IP address management system, where you keep track of all the server, and in front of that server, what IP is assigned to that particular server or application. For example, you have some kind of security incident in your infrastructure, in your network, then you can easily track which IP is compromised and this IP belongs to what server, or other way around as well. If a server is compromised, what IP is assigned to that server, and you can easily track then whether this particular server is talking to another server, or whether it is routed to another server which is critical for you. That's the whole idea, that you have to track all the IP addresses, and you have to track all the servers which are part of your network and which have this IP address allocated to them. Now you might have a counter argument here, that if you assign IPs manually instead of having a DHCP server, and you can have an IPAM system, then you can easily put each IP address, and you can make sure that that IP address have the correct server details or correct FQDNs associated with it. Manually, of course, you have chance of at least having a better record keeping. Only thing is it will make your whole infrastructure or whole your application deployment cycle non-agile. And of course, agile is something which is used day to day. Every application, every software cycle is more and more into this agile way of delivery, where you have frequent new features being released or frequently new applications deployed into the infrastructure. So it really make more sense that you have some kind of automated system for everything, be it IPAM or be it DHCP. AWS itself have its own solution of providing IPAM, its own solution of providing DHCP. We have similar for on-prem systems as well. So it's really making sense that you need to have some kind of solution instead of doing anything manual. Now from networking, let's jump over to the server. When you are booting up a server, we have already discussed about different BIOS mode, different way of having this initial firmware, how they should be upgraded as well. They must be having their own secure way of booting. Once server is up, you have to deploy some kind of operating system into it. Only then you can use that server. And it completely apply for even a virtual machine as well. When you boot up a virtual machine, you should be having some kind of operating system on top of that. Even the containers which we claim that they are lightweight, but they still have some processes onto it. So if you have, for example, your container for nginx or web server, underlying it will be running maybe a minimal image of CentOS or maybe a minimal image of Ubuntu. Everything need an operating system. And that operating system, when you download from a website or when you download from a vendor, whether it's open source or whether it's the licensed version, they all come with some kind of default configuration. If you're buying a full image, then it will be having hell lot of processes. It will be having hell lot of configuration, softwares, applications which are part of that software, that operating system, coming by default. So for example, if you just download Ubuntu 22 or Ubuntu 23 from their distribution portal, you will get everything as part of that image. You will be having Docker by default. You will be having some kind of basic networking manager by default, which you might not use in your day-to-day work, which might not be required for the application, which is ultimately will be deployed on top of that operating system. And if you're not keeping track of what kind of application or what kind of processes are running on your operating system by default, there might be some security incident where someone can actually exploit the vulnerabilities associated with that process, which you even don't need in day zero itself. You can easily stop them. You can easily remove them from your operating system, right? That is called security hardening. So what security hardening does is it creates a set of guidelines which you need to follow to create a baseline configuration. All your application, all your servers, all your virtual machine should be following that baseline configuration. And anything which is not required by your application, anything which is not required by your cluster or your server should be disabled. You shouldn't need it anyhow, any day. So just remove it. Don't keep it there. Keep it running there. And that's the idea behind baseline configuration. And every operating system, when they follow a particular baseline configuration, we call that server or that application is security hardened, because it is hardened with all the irrelevant configuration, all the irrelevant application processes removed from the infrastructure itself. And of course, when you're creating this kind of like baseline configuration, you have to follow some kind of standards or some kind of recommendation, like PCI DSS compliance. They have their own set of requirement. If you are storing a PCI DSS compliant data onto your application, onto your server, then what kind of security hardening parameters should be there, or what kind of baseline configuration you should set. If you are keeping HIPAA compliant data, then you have to follow their recommended baseline architecture or baseline configuration. So security hardening varies from different server to server or application use case to use case. But ultimate goal is you have to follow it. You cannot just leave it as it is, and you cannot just download any open source community version operating system and just run without thinking of or without even considering what is running beside the application or processes which you want to use. What else is deployed onto that operating system, or what else is part of that OS. Now the question is, how you can make this process automated as well. Because if you are discussing about operational aspects, if you are discussing about cloud security operations, you need to automate most of this stuff. You need to automate like IP address management. You need to automate what kind of configuration you want your server to boot up with. And that of course varies what kind of operating system you are deploying at the first place. For example, if you're deploying Linux, it's quite straightforward. You can use any kind of like open source configuration management tool. You can use Ansible, you can use Chef or Puppet to create that baseline configuration, to disable few things, to enable other things. You can easily track or you can easily configure using those tools. With Windows, it's a bit complicated because Microsoft don't like to be associated with open source. Of course, they claim that they are compatible with Ansible and other tools these days, but it's of course much easier if you use Microsoft tools itself. So you can have, of course, group policy object or GPOs. You can push policies from GPOs whenever your Windows machine join to the main domain or main Active Directory. They can have some kind of like policies being pushed from that domain services and enable or disable. Just like Linux, you can enable and disable all those irrelevant or relevant services based on the requirement, based on the use case. Now, what other benefit this whole discussion around security hardening and baseline configuration gives is it also help us in tracking what kind of changes you apply after you have created a baseline configuration. So for example, if you created an application with a particular, particular use case where you have some X amount of processes or X number of system running, you have a new feature for which you require a new version of a particular software, or maybe that new version or new feature which you deployed as part of your application need a dependency which require you to install something new onto your existing baseline configuration. You can easily track it, you can easily document it because you know what was your day 0 configuration and whatever changes you are doing on top of that. In day 1 and day 2, you can easily track it. You can of course have this whole change management board approving it, and you can document whatever changes you have done. And if someone wants to check it, maybe if any auditors comes in and they really want to know why you deployed or why you installed something on top of your baseline architecture or baseline configuration, you can easily showcase them that this was a use case, and for this particular use case we needed this particular dependency, and that's why we installed something. So it's easy to track even for auditing, even for your internal CAM management or change management. So that's why baseline configuration is quite vital part of whole cloud security operation. Now, when we discuss about servers or when we discuss about hosts on which we are deploying our operating system, those hosts itself can be part of a bigger cluster or they can be standalone. And of course, when you think from the perspective of high availability and business continuity, all those fancy terms and all those discussion we had till now, anyone will think why you need a standalone host. You should always go for clustered, right? Well, in a way, yes, but standalone host tends to have those kind of application which are quite critical, and you really don't want to have a cluster of hosts which are running those business critical application on multiple locations. So there might be a use case where you really want to keep everything secure, you really want to control everything on who can access that application, who can access that server, and what kind of information is put there. To make it more easier, of course, it makes sense that you have a single host, and of course, there is a chance that if that host goes down, then you will lose everything. You will lose application access and all. But of course, if there is something really that business critical, I don't think you will be having a lot of people accessing it every day, day in and day out, or even having a public level access. Maybe we can have a compromise of a downtime of couple of hours or day or two, but still it will make much easier to secure those applications. It will be making much easier to have kind of operational control onto those business critical servers. For clustered host, of course, name itself suggests that you have cluster of servers or you have cluster of application which are running together, which have some kind of model, maybe active standby or maybe active, and you have some kind of synchronization mechanism as well. So whatever information you are changing on one application or whatever data you're putting on one application or one server is synchronized and copied over to another server as well. If one of the server of one of the hosts goes down, there's no impact at all onto the people who are onto the users who want to access that application, because ultimately that application is running onto the multiple hosts, is part of a clustered system. And when we are creating a clustered host architecture, inside that cluster of hosts, we can actually distribute the resources. So for example, if I have 4 or 5 physical server, I can make those 4 or 5 physical server part of the same cluster. And now I'll be having 5 times compute power because of that whole clustering which I have configured. And we call it as distributed resource sharing, where the resources are actually distributed across the multiple servers or across multiple hosts, but they are still shared. And if they both want, I don't know, 64 CPU, 128 gigabit of RAM, then how you can deploy it if you have a single server host and that single server host is not having enough capacity, you can of course create those virtual machine onto the two different physical server, and those two physical server will be part of the same cluster. So there is kind of like streamline connectivity between those server. If your one of the server goes down, your VM can, or your virtual machine can easily move on to, we call it auto evacuation, so it can easily auto evacuate to a different server. We can have live migration as well. If you have, for example, some kind of upgrade activity of one of the physical server, you can easily migrate the virtual machine which are running on top of that server to a different server, and there will not be any impact at all, because all those servers, all those physical hosts are part of the same cluster. And if one of the server goes down, if one of the hosts goes down, or if you are manually bringing it down for some kind of security patching, you can easily do it. You can easily migrate the virtual machines across. I think Kubernetes actually follows this whole strategy quite well, and that's why we have worker nodes concept in the Kubernetes, where if one of the worker nodes goes down, your containers or your pods on that worker node will be shifted over to another worker node, and everything will be orchestrated because all those worker nodes are part of the same cluster. This whole resource sharing actually works and fits really well in the whole virtualization concept. Now, in case of virtualization, we were sharing the resources from the same physical server and distributing the resources across different virtual machine. In case of distributed resource sharing, we have made it more broader, and we have all those 5 or 6 or 10 or hundreds of physical server part of the same cluster with their own virtualization layer, and you have now immense amount of capacity, you have immense amount of configuration which your machines or your application, your containers, they can use it, and you can run any kind of application which require a lot of resources without downtime. You can make sure using this distributed resource sharing concept. And if you are distributing resources across and you are making it such agile system that your VM can run on any server irrespective of what it's been assigned on day zero, it can auto evacuate or you can live migrate it. There must be some controller, right, who should be controlling everything, which is part of like cloud management platform. It is a bit like virtualization management tools, which we discussed in the last week episode. We have this cloud management tools or cloud controllers, we call them. In Kubernetes, we call it Kubernetes controller. These controllers, they help in optimization of the resources. So they make sure that if your one of the server is having 80% of resources utilized, while another server in the cluster is having 40 or 20% of resource utilized, then they can move the VMs or move the containers without any manual intervention by themselves to make sure that resources across the cluster is 50% utilization. This is kind of like optimization, which helps improving the allocation of the resources, and of course helps improving the application performance as well, which is running on top of that virtual machine. Because if you have higher utilization, then it might drop the performance of the application which is using those resources or running on top of that server. So it really makes sense that you optimize it every day, and if it's dynamic, then again, no manual intervention and perfect cloud security operations. This clustering, which we discussed about compute, is also applicable for the storage as well. Now, storage servers and storage disk, they also can be created as part of a single cluster. So if one of the storage hosts or one of the storage disk goes down, you still have data copied across. You still have multiple copies of the data. And even if one of the disk going down, even if you have 5 out of 100 disk, all 5 gone faulty, you still have a copy of your data on some other disk. So it really makes sense to use the same concept and apply it on the storage side as well. And we create those big storage clusters if we want to have our data always available without going down or without having access or without having some kind of compromise in the backend. Now, two concepts which are associated around this whole clustering and around this whole dynamic optimization and distributed resource sharing is maintenance mode and high availability. High availability is nothing but making sure your resources or your data is always available, and just like we discussed just now, that it's part of the same concept. If you have 10 or 15 servers all having the same role, what they want to do, they have to supply the resources to a particular application, then even if one of them goes down, we still have another another rest of the n-1 servers still running and still hosting and providing resources to your application. Maintenance mode also is quite straightforward if you have been into IT and you have worked in similar kind of environment onto the backend sysadministrator. But if you are newbie, then maintenance mode is nothing but assigning a status to your application or to your server before doing any kind of activity or before doing any kind of patch update or before doing any kind of reboot. There may be a scenario where you apply some kind of patches, and those patches will only be applied if you have a reboot of your server or if you have reboot of your application. Of course, you cannot do it right away in middle of the day. It might break few things or it might impact the end users. So it makes more sense that you put the whole application or put the whole server into the maintenance mode and then you perform your reboot. All the servers, all the operating system, all applications, be it licensed or open source these days, comes with their own set of guidelines for maintenance mode. So it's really no brainer that you follow those instructions and go with the proper way instead of just randomly rebooting it. Trust me, I have done it and it's really bad if you just reboot it without following the actual guidelines. Maintenance mode is nothing but tagging your system, gradually shutting it down, kill each application or each dependent processes one by one before rebooting it, and then bring it up as gracefully you shut it down so that your application is still intact and it doesn't go spoil. Another key difference here is availability and uptime. Now there might be a confusion where you can think that uptime is equivalent to availability, but it's not. Maybe your server or your application is up but they are still not available because maybe some inline process or some dependent application or server system is down, which can be treated that your application is up but still end users are not able to use it. So there is a slight difference between availability and uptime, and it's worth mentioning when we discuss about all this concept around clustering and high availability of application and servers. Alright, that's it for today's episode, and in next week episode we will discuss things around secure RDP access, how we can have our backup and restore planning, maybe around IDS and IPS. If you are following the syllabus, then it will be topic 5.3, manage physical and logical infrastructure for cloud environment. I'll try to wrap up all the topics of 5.3 in the next week episode because it looks like there are a lot of different things, but most of the stuff we have already covered many times, so I won't invest much time into it and we'll just have kind of like overview of everything, because this particular domain have actually topics all the way till 5.7, so it makes sense that we wrap it up quickly and then move on to the next subtopics as quickly as we can. Alright, that's all for today, and if you are really not following the topics or if you are not really taking time out to study during the Christmas and holiday period, then of course we all deserve a much needed break and take time out with your family and enjoy the time. We can still come back in January and we can still cover up a lot of things. There's really no need to just rush into things. Take it slowly, a step at a time, and of course we will be reaching CCSP soon. And I might be sharing a big news in the next week episode where I might be attaining the status of one of the organizing member of the IAC Square Thames Valley chapter. I have nominated myself and I am waiting for them to decide on. But if they really decide and they really select me, then your host of this podcast will be an IC Square member as well as one of the organizer. And that's a big thing for me. And of course, like I said, if you have something similar going around you, then it really makes sense that you also look into it, and if it's possible, you join that and nominate yourself. If I can do it, of course you can do it as well, maybe in much better way than me. Alright, goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.